Hi friends, Hossein is here. If you're a .NET developer, machine learning is most likely not your main area of focus. But in this video, I'm going to show you how easy it is to get on board with machine learning techniques by using a library called ML.NET. First things first, let's have a quick overview of three main areas. Artificial intelligence started in 1950s and is a computer algorithm that exhibits intelligence via decision making. The second one is machine learning, which started in 1980s and is a subset of AI that assists systems to learn from different types of datasets. Then we have deep learning, which is a fairly new one and is a subset of machine learning that uses several layers of neural networks to analyze data and provide output accordingly. So what is ML.NET? It's a machine learning framework which is open source and cross-platform, first released in May 2018, and since it's part of .NET family, it supports C# and F# programming languages. ML.NET runs anywhere. You can run it on your local machine, on premises, on any cloud like Azure, and since it is cross-platform, you can run it on Windows, Linux, or Mac OS. ML.NET supports different types of scenarios in three major categories, including tabular, computer vision, and natural language processing. ML.NET provides a developer-friendly API for machine learning. Under the hood, it includes several components in four major categories. The first category is related to data ingestion and transformers. The second one includes 40 trainers and algorithms for training ML tasks. The third category includes tools and components for model consumption and evaluation. And the fourth category is related to extensions and tools. For example, you can connect ML.NET to TensorFlow, which is a popular framework in the machine learning space. Like many other popular machine learning frameworks, ML.NET also follows several steps to accomplish ML tasks. It starts with problem statement definition, then we have data ingestion and feature extraction, then we need to train the model. After the model is trained, it should be evaluated, and then it's ready for consumption. The example I'm going to show you is a tabular classification scenario, and it is actually a kind of sentiment analysis on some Twitter posts. So initially I'm going to download a dataset, and then I cleanse the data inside the dataset, create a console application, add ML.NET extension to the app, and then I'm going to define the model details, train and evaluate the model, and in the end, I'm going to consume and test the output. If you head to kaggle.com/datasets, you will find a valuable source of real-world datasets in different fields. They come both in text and image datasets. Some of them are being updated frequently, and some of them are smaller in size, like 106 kilobytes, and some of the other ones are larger, like this one, 107 megabytes. They're free to download, and you can use them in your ML and AI projects. In this video, I'm going to use a fairly smaller dataset which is related to US airline Twitter posts. It is analyzing how travelers in February 2015 expressed their feelings on Twitter. So I downloaded the CSV file and opened it in Excel. It contains several columns and around 15,000 rows of data. Each row is actually representing a Twitter post. There are a couple of things here that we don't need in this scenario. Actually, this dataset is analyzed by the provider, and they have added these labels to each of the Twitter posts. So the thing that we need here is only column B and the text inside the Twitter post. We can delete the rest of them. If we go ahead, we can come up with a simpler version, which just includes a sentiment and a text for each. So I have just created a console application targeting .NET 7. Nothing special inside the program.cs, and I've just added a folder called data and added the cleansed CSV file that we downloaded. Next step is to add ML.NET to our project. I right click on the project. From the add submenu, we should choose the machine learning model. If you don't see this option in your Visual Studio, you have to follow the steps I've provided in the description section below. I click on the machine learning model and choose a name for the file. I call it sentiment model. Then add. So this is actually the pipeline that I explained inside the slides. It goes through several steps in order to build the model. The first step is to select a scenario. As I mentioned, I'm going to choose a data classification because we need to classify data and figure out if a Twitter text is either a negative, positive, or neutral sentiment. So I choose data classification. The next step is selecting the environment. As I'm not connected to anywhere else like a cloud provider, I should use my local CPU. So I select this one and click on the next step. The third step is about data ingestion. So we need to provide the data to the model. Here we can choose a CSV or text file or a SQL Server connection. I'm gonna click on the browse and navigate to the data folder which contains the CSV file. As soon as the data is loaded, it is going to give us a data preview. And it asks us about defining a column called label. And that is the column that the model should predict eventually. So whenever we provide a text to the model, it should figure out the sentiment of the model. So we choose the sentiment as the label here. In the fourth step, it is going to train the model. We should provide the number of seconds that it can occupy the CPU in order to train. I enter 30 seconds and start training. Based on the time that we provide here, it is going to train the model with different trainers. And in the end, it is going to choose the one with the highest accuracy. So in this step, it is going to do the evaluation. It has already selected the best model and it gives us a sample in order to test the model. So one record has been selected out of the CSV file and we can click on the predict button and it is going to analyze it based on the trained model. So the result is that it is 52% negative, 26% neutral, and 22% positive. In this step, we are ready to consume the model. So it gives us several options. We can either copy a code snippet which is provided on the top, or it can go ahead and create two kinds of projects for us, either console app or a web API. I'm gonna go ahead with the code snippet option. So these two last steps are optional. One of them is related to deploying our model to a cloud provider like Azure, and the other one is related to improving the performance of our model if we are not happy with that. So I have copy pasted the code snippet and modified it a little bit so we can see a nicer output. I have also added 3 sentences that we can pass to the model and check them. I'm gonna run the application. For the first sentence, the text is the 2-hour delay is not acceptable. So the model identified it as a negative sentence with the accuracy of 93%. The second text says that that was a great offer for Christmas holidays. So the model identified it as positive with a score of 81%. The third sentence says that nothing competitive from the other options. Okay, it's somehow neutral and also negative to some extent. So the model scored it 43% as neutral and also 40% as negative. So it seems to be fair. So you could see that running a kind of scenario inside ML.NET is not that complicated. So you can go ahead and try the other types of scenarios with different types of datasets.